afternoon, guys. All right, so today we're going to be doing Chapter 1, Lesson 5, Algebra Multiplication Patterns. It is in pages 21 through 24. Please make sure that you are taking notes on this portion. Always take notes for math because when you write it, you recall things as well. So the I can statement that we have today is I can use basic facts and a pattern to multiply mentally by multiples of 10, 100, and 8,000. So the key word here that I'm going to be highlighting is basic facts. And I hope, yes, awesome. Basic facts. So any basic fact, basically your times table, those are basic facts. And you're going to be finding a pattern with multiplication and powers, or multiples of 10, 100, 1,000. Multiples of 10, 100, 1,000 are like 10, 20, 30, 40, 50, 60, 70, 80, 100. Multiples of 100 are 100, 200, 300, 400, 500, 600, so forth, so on. Same thing goes for thousands. The first magnifying lens. Did you know that the first magnifying lens were developed in Italy in the 14th century? In 1590, the first microscope was made by putting two lenses in a tube. What are some things that you can study by looking at them through a microscope? So think of tiny, tiny, tiny little things that you can use to look at things with a microscope. Now remember, a telescope is different from a microscope. Good, you should have said anything little. Could be a algae, could be dust, it could be insects, cells, crystals, bacteria, anything small. So we're going to be learning about how close have you been to a bumblebee before. This is on page 21. We're going to read the little paragraph we have at the top. The actual length of a queen bumblebee is 20 millimeters. That's small. So think of a centimeter, which is about the width of a dime. I want to say that's what a millimeter is, the width about a dime. So it's really, really small. This photograph that you see in your book shows part of a bee under a microscope at 10 times its actual size. What would the length of the bee appear to be at a magnification of 300 times its actual size? All right, so we're going to be thinking about 300 times 20 millimeters. So here is the multiplication that you have in your book. Something really, really important, use basic facts first, okay? We have to multiply 300 times 20 because we want to, I'm going to go back to our little word problem. We want to see the size of a bumblebee and what it looks like magnified 300 times. So let's go back. So we have 300 times 20. So you want to do the basic fact. Obviously 3 times 2, we all know that, which is 6. And then as we look forward, we know that 30 times 2, which is the basic fact of 3 times 2 times 10 to the first power equals 60. And I'm going to go ahead and use my pen here. So here's should be noticing something here. It's a pattern. 300 times 2, which is the basic fact of 3 times 2, times 10 to the second power. So our answer would be 600. Then we have 300 times 20 is 3 times 2. That's how we use the 3 and the 2. And then 100 times 10 equals 6 times 10 to the third power, which is 6,000. Okay, so the length of the bee would appear to be about 6,000. No! I don't know what happened. Oh, okay. 6,000 milliliters. So that's really, really important to see. As you can see, you want to use your basic facts first, and this is showing you what is happening. I hope you're noticing some sort of pattern that is reoccurring. Why was 300 times 20 used to find the length of the magnified B? We kind of talked about it. The reason why we use this is because the actual size of a B is 20 meters, my apologies. But we wanted to magnify it 300 times. So that is why we multiplied it. Why do we use exponents in multiplication? Why do we have 10 to the second power? Good, you should have learned from yesterday. We use that because it makes it easier to count the amount of zeros, and it's easier also to write one factor instead of having to do times 10 times 10 times 10, or however many times you must do it. Why does the last line in the pattern have the power of 10 to the third, or through the third power of 10? You should have noticed that is because the 20 over here has a 0. Okay, it is 20 could be considered 2 times 10. And so you have that 10 in there that needs to be multiplied with the other 2 10s, which are in the hundreds. And that's how we get 10 to the third power, which is the same thing as 1,000. And yeah. All right, the question on also page 21, it says, what pattern do you see in the number sentences and the exponents? Let's go back. Here we have, I'm going to go ahead and clear our notations. Here we had 600, here we have 6,000. What do you notice about your answer, the zeros, and your exponent? You should have noticed that they're equal. You see that 10 to the first power has 1 0, 10 to the second power has 2 zeros, 10 to the third power has 3 zeros. And this is because 10 to the first power is just 10 times 1, 10 to the second power is 10 times 10, which is 100, and 10 to the third power is 10 times 10 times 10. So the exponents and the number of zeros in the product increase as the number of zeros in the factors increase. All right, so here is what we must multiply. We are multiplying 50 times 8,000. We must remember to use basic facts first. So why did we start with 5 times 8? Good, because that's the basic fact that we have. All right, good, very nice. Let's go ahead. Since we know that 5 times 8 equals 40, this will always be 40 right here. Good. Then we need to go ahead and multiply it by 10 to the first power, and that equals 400. And we're just taking it step by step so that way you can see why we're doing it, why we have powers of 10. See, then we're going to go ahead and make our 8 to 800, and that's why we have 10 to the second power. And we have our 8 to 800 still, but then now we change 5 into 50. So there's the 50, and then here's the 100, and that makes it 10 to the third power. And then here we have 10 to the fourth power, because we have 10 in our 50 right here, and then we have 1,000 in our 8,000. All right, let's get my pencil, and we should have here. Oh, I guess I'm using this one. Good, and then over here we should have oh, I like this. I like using the highlighter. Okay, so my next question here is no.
Danielle Banter, are you still on campus? Buzz the office. Danielle Banter.
No, I had some questions here, but they're not coming up. So I'm going to go ahead and talk about it. Why is it that we see the 40 here? Why is it that here we have to the first power, but we have 2 zeros? And here we have to the second power, but we have 3 zeros. We have to the third power, but we have 4 zeros, and we're at the 4th power, and we have 5 zeros. Good, you should have noticed that because of our basic fact, which is 5 times 8 equals 40. That ends up giving us that extra 0. All right, I would like you to give an example of a multiplication expression that has a product with more zeros than the factors, and explain why this is. So, an expression where when you multiply, your product has more zeros than the factors. And it's kind of how like that previous one that we just did. Here I had one. We had 20 times 50. Do you see how my product has 3 zeros, but my factors only have 2 over here? Well, the reason is because of our basic fact. 2 times 5 gives me 10. And that's where we get that extra 0. And then don't forget, because they're in the tens place, we got to multiply it by 10. And that's how we get 1,000 as our answer. Oops. There's a 0 in the product of the basic fact of 2 times 10, which is what I showed right there. Awesome. All right, go ahead and pause and complete, then press play for the answers. Awesome. So let's go ahead and use mental math and patterns to find the product. Now, remember, you want to use the basic fact. What is the basic fact of 30 times 4,000? Good, you should have said that it was, I'm going to go ahead and use a pen instead. You should have stated it was 3 times 4 is your basic fact, and you get 3 times 4 equals? Good, 12. Then, because you have your basic fact, and you have the amount of zeros here, you can go ahead and place your answer. And now remember, it's because this is 30, and that's in the tens place, and this is 1,000 over here. And when you multiply those together, you get 10,000. All right, the next one, use mental math to complete the pattern. 1 times 1 equals 1. 1 times 10 to the first power equals 10. 1 times 10 to the second power equals 100. 1 times 10 to the third power equals 1,000. Good, then let's go on to the next one. We have 7 times 8 equals 56. So we know that this will, my bad. I want to use now this one. 56, right? 56. Now we have 56 times 10 to the first power, which is 560. Then we have 56 times 10 to the second power. We have 5,600. And then we have 56 times 10 to the third power, which is 56,000. Good. All right, go ahead and solve this one. And I did this one separate because I have some questions for it. Go ahead and pause and complete it. And then I'll press play. Good. You should have done 6 times 5, which is your basic fact, which is 30. Okay, so you could even I like to know that I have 30 over here. All right, then you need to do 30 times a number equals 300. Now, here we see the 30. Do you see the 30? So then what do we have? Good. You should have said times 10. Now I'll do the same thing here. Here we have the 30. How many extra zeros do we have? 2. So that would be times 100. Then the next one, how many extras do we have? 1,000. Good job. Very nice. So there are 2 zeros in the second product of the pattern. By what power of 10 did you multiply? Good. It should have been 10 to the first power. And I went ahead and actually just put the actual answer. You would want to use it in powers of 10 because that's the instructions, I believe. Then you have 10 to the first power, and then so then this other one would be 10 to the second power, and then 10 to the third. this one would be 10 to the second, 10 to the third. Now my next question is, since there is only one zero in the first power of 10, why are there 2 zeros in the product? So kind of similar how I previously been talking about, and I want to just reiterate it multiple times because it's really important. Even though this tells me 10 to the first power, but we have 2 zeros because of this, because our basic fact has 30. Keyword is power. Please make sure to let me know whenever I ask you this in the morning tomorrow. Oh, my bad. All right, go ahead and complete page 22, problems 5 through 10, and then I will go ahead and show you the answers so you can check your work. Make sure to pause it. All right, there it is. You can pause it to look at it. Oh, okay. Now go ahead and do page 22 as well. Problems 11 through 19. Don't forget to pause, and then I'll go ahead and go to the next one. Good. There is your answers. Now let's work on this table on page 23. It's going to be problems 22 and 23. So we have 80 times 6. Oh, well, let's highlight some stuff. Over here we have some numbers, right? We have 6, 70, 80, 90. Then over here we have some numbers, 80 and 90. And over here we have the product of those things that we're multiplying. So I am going to use a pen, and let's use a darker color. So here we want to do the basic fact, which is 8 times 6, which is, good, it is 64. I'm sorry, 48. What am I saying? 48. And then times 10 because of that extra 0, and that would be 10 to the power 1. Then we would do the next one right over here. We have 8 times 7, which equals 56. And because we have 2 10s here, it would be times 10 to the second power. Put those in parentheses. All right, then we move way over here. Then we want to do our basic facts, which is 9 times 8, which is 72. And then multiply it by the power of 10 to the 4th, because there's 3 here and then 2 over here. Let's move on to the next one. You have 9 times 6, and then there's only one thing that you're multiplying, so it's 10 to the power of 1. Then we have 9 times 7, and because it's 70, you should multiply it by 10 to the power of 2. And then next one we have here is 8 times 9, and here we have 2 zeros, and then over here 1 0, so it would be times 10 to the power of 3. And here it looks better. Awesome. So that is actually the end of my presentation. Don't forget your keyword. Don't forget to complete this, and I'll see you tomorrow morning. Also note that tomorrow we will be studying the mid-chapter checkpoint, because on Monday we will be having the checkpoint, or a mid-module assessment, mid-chapter assessment. Thank you guys. Have a good evening.